Overview 3.12 Congruence and Rigid Motion, where I go over the questions in your assignment. First question, the coordinate could be. The coordinates of the vertices of triangle DEF are D, -2, 3, E, -1, 7, and F, 2, 1. The coordinates of the vertices of triangle D prime, E prime, F prime are D prime, 3, -2. First thing you need to do is notice what happens from D to D prime. E prime is 7, -1. Notice the same thing happens. And F prime goes from 1 to, notice the same thing happens. So which statement is correct? Does triangle DEF not congruent to triangle D prime, E prime, F prime because there's no sequence of rigid motion? Or is triangle DEF congruent to triangle D prime, E prime, F prime because you can map DEF to D prime, E prime, F prime using 180-degree rotation about the origin, which is a rigid motion. So rotation is a rigid motion. The question is it a 180-degree rotation? Triangle DEF is congruent to triangle D prime, E prime, F prime because you can map DEF to D prime, E prime, F prime using 90-degree counterclockwise rotation about the origin? Or is this not a rotation at all? Is it a reflection across the line y equals x? I highly suggest you get out those rules of transformation that we learned about in our lesson and that we've been taking snippets of to answer this question. Next question. A parallelogram is transformed twice. First, by using the mapping rule, xy maps to y opposite x, and then by using the mapping rule, xy maps to x to the right 4, y down 3. Select. Well, we don't have drop-down menus, so instead, you're just going to choose fill in the blanks. The image 1 is or is not congruent to the pre-image because, so it either is or it isn't. The first transformation is not rigid. The second transformation is not rigid. Or maybe both transformations are rigid. Again, you're going to need your transformation rules to determine this. And please, please remember that translations, rotations, reflections are rigid motions. Dilation is when we multiply the x and the y, and that is not a rigid motion. Triangle XYZ is mapped to triangle X prime, Y prime, Z prime using the rule XY maps to opposite X, opposite Y, followed by XY maps to 0.75 times X, 0.75 times Y. Which statement is correct? Triangle XYZ is not congruent to triangle X prime, Y prime, Z prime because the rules do not represent a sequence of rigid motion. Or maybe they are congruent. Is dilation a sequence of rigid motion? We know translation is. The coordinates of the vertices of a pre-image are M, 0, 0, N, 1, -4, and Q, 8, -4. The coordinates of the vertices of its image are m prime, 0, 3, n prime, -1, -1, and q prime, -8, -1. Which statements correctly describe the relationship between triangle MNQ and M prime N prime Q prime? Triangle MNQ is congruent because it's a reflection across the y-axis followed by a translation 3 units up, or they're congruent using a translation 3 units up, or they're not congruent because there's no sequence of rigid motion. Or maybe they are congruent because we used reflection across the x-axis followed by a translation 3 units up, which is a sequence of rigid motion. All right, on this question, Marta is proving that triangle ABC is congruent to triangle A prime B prime C prime by the SSS congruence postulate. What are the lengths of the congruent sides? Enter your answers in the boxes. Notice here that we have AB is congruent to A prime, B prime, C prime because the length of both sides is 2 units. BC prime, or BC, sorry, is congruent to B prime, C prime because the length of both sides is. And finally, AC is congruent to A prime, C prime because the lengths of both sides is how many units? Keep in mind that AC is the square root of 2 squared plus 3 squared. Okay, or the square root of 4 plus 9. So we're going to get the square root of 13 here. Allison is using rigid motion to prove the triangles are congruent. What rigid motion can be used? Enter your answers in the box. The triangles are congruent because you can reflect the pre-image across the X and then translate the result blank units down. And both of the transformations are rigid. So X equals what? Units down. And then we can go ahead and reflect it. So how many units down did we move? Which statement correctly describes the relationship between the triangles? Triangle PQR is congruent to triangle P prime Q prime R prime because you can map them using a reflection across the y-axis and a reflection across the x-axis, which are both rigid motions. Or they are congruent because you can map them using a reflection across the x-axis and a translation 3 units down, which are both rigid motions. Or they are congruent because you can map them using a 90-degree counterclockwise. That means it turns to the left. Rotation using the origin and a reflection across the y-axis, which are both rigid motions. Or these are not congruent because there is no sequence of rigid motion. couple more questions here. Remember, you do not get all of these, so feel free to stop, pause, rewind, fast forward this video through any of these questions that you need. Which sequence of transformation maps triangle ABC onto triangle DEF? Select each correct answer. Can we reflect triangle ABC across the x-axis? Reflect the resulting triangle across the y-axis? And then translate the resulting triangle 1 unit down? Can we translate triangle ABC 1 unit down? Then rotate the resulting triangle 180 degrees about the origin? Or would we reflect triangle ABC across the y-axis, then translate the resulting triangle 3 units down? Or could it be that we translate triangle ABC 1 unit up, then rotate the resulting triangle 180 degrees about the origin? And which statement is true when considering triangle JKL and triangle MNP? Remember, you are looking to see if these are congruent or not congruent, and which rigid motions you are using. If they are not the same shape or the same size, then you would say they are not congruent. And you would say why they are not congruent, such that they do not use a series of rigid transformations. Each choice has a sequence of 3 transformations that a pre-image undergoes to produce an image. Find the ones that are correct. Remember, if it says that it is multiplying x and multiplying y, that means that they're mashed together, then these are dilations. And dilation is not rigid motion. The same thing is true with this one. Anything that is mashed up against x and y is being multiplied. Therefore, this is not rigid transformation. So in this one, pay close attention because you might be saying that this is not congruent because it's not rigid motion. So you may be looking for the one that is being multiplied to make it bigger or smaller. If you have any questions about this assignment overview, please text or call me at this phone number below.